if you have any questions, there is an office in 318. It's my office. You can contact me before you come if there is any problem. And that's my widget. This is my widget. So, and there will be a group in the QQ, and you can ask me in the QQ group as well. There will be a QQ group. The week duration is 8 weeks to 13 weeks. Short course. All the course needs some prerequisites. Prerequisites means what you need to study before. I'm sure that you already started this Laplace. You know the Laplace, right? Laplace transformation, Fourier transformation. These are basic tools for the control system, matrix and MATLAB. So, and differential equation. These are some basic tools you need to study that before you study this course. This course, that's why we call it prerequisites. I will upload all class notes, lectures, PPT, assignments, everything in the QQ group. You have a QQ group, right? So I will upload everything over there. There are one textbook, English textbook we will follow. That textbook called is Modern Control Engineering by Kogata. He is a Japanese writer and scientist. That's the book. I will provide you this book. I have a PDF. I will upload it in the group. I have this edition, 5th edition. Most of the contents actually taken from this book. So this is our textbook, and you already have a Chinese textbook. This Chinese textbook also have the same content of this book, same contents. So this is the two books. There is a reference book, Chinese textbook. I think there is the one you already have these books. So if there is any problem or if you do not find a solution, you can check here. This book, you will find the solution over there. So, what's the objective of this course? This course name is Control System. Fundamentals. Fundamentals means basics of the control system. So the basics, what we will learn, the basic methods of analysis of design of automatic control system. That is what we will going to learn in this course. Fundamentals or the basics of automatic control system. And how do we model it? How we can model that system? How can we model? To do the modeling, we need to know, we need to understand about the mathematical analysis, mathematical modeling. Mathematical modeling means the mathematical analysis. So we will talk about it, we will study this in this course. Then later on we will design and analyze the automatic control system based on two different domains. One is time domain. Another one is frequency domain. These are the very basic tool for analysis or analyze any control system. Analyze in time domain, analyze in frequency domain. So here we are going to learn these things, the objectives of this course. This is the outline of this course. We will talk about the different types of control systems, the basics introduction in this today's lecture. Then we will talk about the modeling, mathematical modeling. Then we will talk about the transfer function and block diagram, signal flow graph, time domain analysis of first order and second order system, then route harvest stability criteria, the frequency domain, Nyquist stability, body plot, and different controllers. All the contents you will find here in your book, in your Chinese textbook. All the contents are there. So if you do not understand any English term over there, you can read the Chinese textbook. You can find all the terms over there. You are not familiar with my evaluation. Evaluation is the same. Like we don't have any labs here, so we have theory only. So there will be attendance 20%. Assignments, I will provide you some assignments, 2 assignments, 10%, performance 10%, and final exam 60%. So together it's 100. I will provide you the assignment, I will give you the assignment, and I will not allow the late submission. Submit all the assignment to the due date. No late submissions. And attendance, you are already familiar with the attendance. Do not absent in the class. Any questions? Today's lecture is based on an introduction of the control system. We're going to learn the basics, trying to introduce the control system, different types of control system. So what is a control system? System that will control, that actually called the control system. A system that will control by another system. Suppose this is a system. This device, what is this? Screen. This is a screen. This is a system. How I am controlling this? By using this. So this one is the control system. So a system is controlling by another system. This is called the control system. So from these two systems, which one is control system? This one is the control system. Because I am controlling forward, backward by using this device. So this one is the control system. So a system is controlling the operation of another system. We call it a control system. A system that can regulate itself and another system. This system, I don't need this system to control by another one. It can operate itself. I don't need another system to do this. So this system, this control system can operate itself. Also it can operate another system. So the overall definition is a control system is a set of device or a device that command, that operate or regulate the behavior of another system. Just like this. Here I have a fan, this fan. I have a switch. This is the control system. This is a system. So this system, we call it control system because this system is operating of this system. This system is commanding this system, increasing, decreasing, on and off. So this system also we call it a control system. This system we call it a control system. So all the system, if it operate, manage or command of the behavior of another system, we call it a control system. The basics. This is the definition of a control system. So how can we actually explain it? There is a block diagram. So in this block diagram, this is a whole control system. The whole system here. This portion, we call it a control system. Why? I have an input. input, and based on this is a system. This is a system. In that system, I will provide an input. I will provide an input. How? Through a control system. The input will be provided to a system. System means plant. Mostly in a control system, we call the system is a plant. So we will provide an input to the system by using a control system, and we will get an output. Simple. Now inside the control system there are different devices, because it is a set of device. Algorithm, that is program. You write the program. What program? C, C++, all this program you will write, control algorithm, or any other program. Anything. That's the algorithm you will write. Then there is an actuator. This actuator mostly works to convert this input to a physical force, torque, displacement, acceleration. Force, torque, displacement, acceleration. This will be converted to the input. The input will be provided, it will convert that, and it will send it to the system. And then this whole control system will send this to this system, mostly we call it open loop. This system we call it an open loop system. So after that we will get an output. Now, when this output is sent it back to the input again. When the output is sent it back to the input again, that time we call this system is feedback system. Feedback. And this system we call it automatic system. If the output is not sent it back to the input, if there is no feedback, then that system is not automatic system. That system will not call an automatic system. The automatic system will be when the output is sent it back to the input again. If it is not, then the system will call open loop. So when the system does not have any feedback, that one we call it an open loop control system. If the system having a feedback, that we will call an automatic control system. These are the basics. We will explain it in more details later on. Now the system will get some input, will fed the input. This input will fed to the system through a control system, and we will get an output that we actually call it an open loop system. And if the output is sent back to the input again, that we will call feedback system, or what actually we call it automatic control system. Now automatic control system objectives. What are the objectives? Three main objectives. One, we always want a stable automatic system. Stable. So maintaining stability is very important. How do we maintain stability? You see here, we have an input and output. So, we measure the stability by measuring gain. This is called the gain. Output by input. This gain can be any gain. voltage gain, current gain, power gain, or torque gain, anything, any gain, whatever it is. So stable system has constant gain. So a stable system has a constant gain. Constant, all the time it is fixed. It will not change. Open loop gain, open loop system does not have a constant gain. In a closed loop system having a constant gain, or feedback system or automatic system having a constant gain. So maintaining stability, that means maintaining the constant gain and phase margin. Second, follow the set point. SSE. SSE mostly we call it steady state error. This is called steady state error. Where? Here, look. Here, if you see in this diagram, I have a term called error signal. This is called SSE. How do we measure it? We measure it from the input minus feedback. This is the feedback signal, feedback. So input and feedback difference. Here, the input and feedback differences. We measure the steady state error by measuring the input and feedback difference, the difference. The less difference, the less steady state error. The more difference, the more steady state error. So we want a less steady state error, or almost zero. A control system, good control system having a very small or almost zero steady state error. Control system. A good control system having a steady state error almost equal to zero. That means no steady state error. But theoretically it is possible. Practically that's not possible. Practically you will find some. So SSE, we need to measure the SSE. Rise time, settling time. Rise time and settling time mostly we measure it while system, this is an input. The input reach to from 0 degree, 0% to the 100%. The time requires, this time we call it rise time. And the time required, actually this is not like that, this is like this. So the time required to reach to the steady state position, that is called settling time. We will talk about this rise time, settling time later on. The time required to reach from 0 to 100% of the output, it's called the rise time. And settling time, the time required to reach to the steady state, fixed state, stable state. That is called the settling time. Reject disturbance. When we have an input and we use a control system to a system to get some output, there will be some disturbance. That disturbance, we call it noise. Noise happens while we use this sensor, actuator, plant. There will be a noise with the signal. How do we can measure the signal? Suppose this signal, no noise. And here, if you see, here, signal with noise. The signal having noise. That's why you are not having a smooth curve. There is a noise. There is no noise. You are getting a smooth curve. So, and you use some digital devices like sensor, actuator, and plant, and you will get an output. That output must have some noise. So the noise has to be reduced. We will talk about how we do the reduce the noise. We will talk about it later on. So we need to reject the disturbance. We need to reduce the noise. So there are three things. One, maintaining gain, constant gain. Maintaining a constant gain for a stable system in a automatic control system. Two, follow set point, steady state error. We need to minimize the steady state error. SSE has to be almost equal to zero. Almost equal to zero. That means no steady state error. So we need to make to get a good control system or good automatic control system. Third, reduce the noise when we are using sensors, actuator, or any digital devices. We must need to reduce the noise or disturbance. So these are the objectives of the control system. We need to do that. Alright, so what actually I told you about the definitions, like the system. System is a combination of different types of devices, set of devices, any types of devices that acts together and perform a certain objective. Suppose this is a system. What it does, it gives an output. It shows the PPT. It is showing the PPT now. So it is the output. It is maintaining a certain objective. What is the objective? It is providing output. That's it. But a control system, it is actually provides a desired response. It does not perform a certain objective all the time. It performs what we desire. So, what we desire means I am pressing this forward. I am pressing this backward. So it is going forward and backward all the time. So it is my desired response. It is what I want. That's why we call this a control system. This one, I turn it on, the fan will turn on. This is what I want. I turn it off, it will turn off. So this is what we want. That is called the desired response. So the control system, it will provide a desired response. That we call it a control system. And the process means mostly we call it a system. I already told you the plan. We use in block diagram in control theory. We use this word plan. We don't use the system. So the plan or process or system which is under control by a control system, that is called a process. So this device is under control by this. This device is under control by this. So mostly we call it, while we provide an input, it will go through a process and we will get some output. So the process is the system. Mostly this system will be controlled by this control system. So in the process we will have a control system. Alright, now this diagram, the block diagram, it look like this because we need to use a controller to control this. We need to use a controller to control this. So here input, whatever it is, we can provide any random input. Set point, we will fix some fixed point for the input. The random input, fixed input, or some references. We can provide any. We can provide any types of input. So all the inputs will send to the process through a controller. This controller manipulate this. Manipulate means change. It will change. Here, I am providing input. Look, the fan will goes very high, very low. How? Because of this input, I am providing input here. It will change, manipulate it. That is called manipulation, change. It will change the input. It will change the set point. It will change the reference. And based on that, we will send the input to the process. And then we will get an output. So the gain will be the output by input. And that gain, after that, we can send it back. If we send this one is back here again, then we call it a control variable. Control, because this output is sent it to the back, and we find out steady state error, SSE. We find out steady state error, and we compare it, then send it back to the output again. It will go through the output again and send it back to the input again. Go through the output again and send it back to the input again. So that is called controlled variable. Controlled variable only happens in automatic control system. Disturbance, mostly it happens while we use this automatic control system. This disturbance, we call it noise. It is the unwanted input. Noise, we call it unwanted input. It is, we do not expect that, but it happens. Why it happens? Because of this weather, because of the magnetic in the sense of there are different magnets. Because of this magnet, there is a magnetic conduction, so we call it electromagnetic conduction or electromagnetic conductance. Because of that, the noise or unwanted input, it happens. Now this unwanted input happens by two ways. One, we call it internal disturbance. Internal disturbance happens while there is the sensors we use, different actuator we use, or the plant we use. Internally, inside the device, there are certain devices. Because of those devices, internal disturbance happens. And external disturbance mostly happens, it generates from the outside of the system. Outside of the system, because of the condition of the weather, temperature, pressure, humidity. The temperature, now it is low. In the summer, it is very high. Because of this weather, pressure, if you go up, the pressure will be low. If you go down, the pressure will be high. Because of that, humidity. So all of this makes actually the external disturbance. So there are two different noises can be happens, internal disturbance and external disturbance. Internal disturbance only happens because of the devices that are used inside the device. And external devices, external disturbance happens because of the different external weather condition. So basically there are two types of control system. Generally what we see, two control systems. One we call it manual control system, and second one we call it automatic control system. Manual control system. Here, this one, I am pressing it up and down, going forward and backward. Is it manual or automatic? Anyone? This, I am pressing up, down. So it is going up, forward, backward. Is it manual or automatic? Anyone? Manual am pressing it, then it is going forward. I am pressing back, then it is going backward. It is manual system. Over. So, why this system here, this one, we are pressing it higher, then it goes faster. Which system? Manual system. This system, turn it on, the light will on. Turn it off, the light will off. Manual system. So that's a manual system. Now there is an automatic control system. This air conditioner. Controlling the room temperature through the air conditioner, you turn it on. That's it. You keep it the remote. The room will be cooled automatically. Controlling the room temperature through the AC. Here, this is automatic control system. So there are two control systems mostly we see by our eyes. We see by our eyes. Automatic and manual control system. Suppose here this guy is looking to the water level. This is the water level. This guy is looking to the water level and turn it off, the valve. Turn off the valve of this, so that there will be no water flow because it is full. That is manual system. Remote, the AC remote, you turn it on. Keep it. The room will hold automatically because the AC will control the room temperature automatically. That is automatic control system. So there are different types of control system. What actually we have seen, we use all the time. Manual system and automatic control system. Now, why we need this automatic control system? What are the needs of the automatic control? Automatic control is very important for industrial applications, mostly industrial applications. You have seen in the industry there are very big machines are installed. Very big machines are installed. To control this manually, it's very tough. To control all those big machines manually, it's very tough. So for those process industry, automatic control are very important and essential to control the pressure of those machines. Pressure. What is this? Pressure mostly we define it by T. Control P. Control in T. Temperature, humidity, RH. Mostly we control this in an automatic by using automatic control system in a process industry. In the big industry, the machines that we use, we control the pressure P, we control the temperature T, we control the relative humidity RH. So all of these we control. It needs to be done automatically because manually if you want to control pressure, if you want to control temperature or RH, it takes a long time. Many people needs to be involved. It's very boring as well because people need to do it all the time, do the same thing all the time. So it's very important. If we use control system, it will be done automatically, just like the control system is controlling the temperature of the by using AC, just like that. So the flow of or viscosity, everything we can control. Viscosity is the thickness. So the fluid thickness mostly we also need to control that. So automatic control mostly helps the optimal performance of a dynamic system. Dynamic system means changeable system. What the system that we have here in the real world, it is not a fixed system. There are two types of systems. One, fixed. Another one, dynamic. Fixed means this. It is situated here, fixed. It is situated here, it is fixed. But dynamic, like I am walking, it is dynamic, it is continuous, it is changing. I am changing I am walking here and then I am going there. So it is a dynamic system. The real world system, it is like that. It is always changing. It is always changing. It is not fixed. Automatic control system helps to get optimal performance of those dynamic systems. And also it improves the productivity. Productivity means it gets good gain, high gain. And also it actually do some reduction of the repeated operation, because if a person or the technicians needs to do this manually, it takes a long time, it will be repetitive, it will be hectic, it will be boring. So automatic control system do all of these things. Suppose here there is an example. This is a water level. Look at the water level here. This is an automatic water level controller. Automatic water level controller. How it is controlling water level? These are the water level. Now there is a valve. This is called the valve. This valve is connected with this. Look. Now, while this valve is here down, it goes up. This one goes up. So the water will flow. The water will flow. It goes down. Goes down. The water will flow highly. High flow. High flow of water. Now, this water level, when it goes up, because there will be a water flow, the water level will goes up. Water level will goes up. Water level will goes up. The water level will goes up. This will go up. When it will go up, it goes down. It goes down. So what happens? The water flow will decrease. Lower flow of water. The water flow will decrease because it goes down, and finally while it goes to reach to the peak point, it goes down here. It blocks. It blocks. That means no water flow. No water flow. No water flow. That means the water flow is controlled. So water flow is controlling by using this valve. Before it goes down, it goes up, high flow of the water. As the flow, the water level goes up. It will go up and it goes down. There will be a lower flow of water. The water flow will decrease, and finally when it to the peak point, it will goes to the pole. It will block the water flow. No water flow. So this is called the automatic control flow, automatic water flow. So that is called the automatic water level controller. This is quite common. We are using it for a very, very long time. Many years ago we are using it. That is actually before, like 50, 60 years before, from their time we are using this thing. Alright, now here I am explaining what are the variables that are actually involved here. What are the variables? Now, in a control system, I already told you there are two variables. One controlled variable, another one uncontrolled variable. So now, which one is the controlled variable? The controlled variable. The controlled variable is the tank level. What is the tank level? This is the tank level. This is the tank level. So tank level is going up from the below. So this is called the control variable in this example. And it will reach to the specific range. The range is this. And this is the range. This is the range of the water tank level control variable. Why? Because there is a fixed range. Fixed. This is fixed. The range is fixed. It cannot change. This range is fixed. It cannot change from here to there. Once it reaches there, it is 100%. It will off. So it is 0%, 0 to 100. So it is fixed range. That's why we call it control. It is control variable. But there is another one that is called the uncontrolled variable. This is the water flow. Water flow rate is uncontrolled variable. The water flow rate, it goes up and it goes in this direction. The water will flow in this direction. We don't know how much is the water is flowing. Uncontrolled variable. So what do? We need to control this. It is uncontrolled. So we need to control that. How do you control it? By using this system. And this system is called the control system. This is the control system. So what the control system does? Control system controls the uncontrolled variable. This is uncontrolled variable. The water will flow. We don't know what is the flow. Water flow rate. We don't know the flow rate. It is uncontrolled. So it can go to the infinite times. So we need to control that. So how do you control it? We need to use a control system. And this control system goes down and finally stop the water flow. So this uncontrolled variable can be controlled by using a control system. This is actually what the control system does. So in a process variable, in a automatic control system, there are two variable, control variable, uncontrolled variable. So control variable, it is fixed all the time. In any control system, it is fixed. But the manipulated variable or uncontrolled variable, that needs to be controlled by using a control system. Here, the water rate is the manipulated variable. Let's take the break.